by the body. Yes. I'm waiting for you. How do we determine the maximum height?
H is equal to U square over 2G.
Exactly. So U squared over 2G would give us the maximum height. So help me calculate that for me. Maximum height.
Mr. Dia,
Yes.
Mr. Dia, please
Yes.
I have a question.
Ask.
The other formula on the board,
Hmm.
the H is equal to C plus, do we use it when we are just finding the height?
You see, we can also use this to find the maximum height, but we can only use this when we know the
Oh,
time taken to reach the maximum height. We don't have T, we have U, we have G, but at least we also know that the time taken to reach the maximum height, Nana Safo, is equal to Safo.
Yes, please.
I said the time taken to reach the maximum height, this will be equal to what?
It's around
Pardon? Janice, what will be the time taken to reach the maximum height?
so please U over G.
So this will be U over G. So what I'm saying is that we can also use this, but you can use this when you have T. So if you want to use this, then come and calculate T first and substitute it into the relation. Is that okay?
Yes, please.
So it means we can use this or use this. And let's confirm. What is the velocity of projection? The initial velocity given to the body. What is the initial velocity given to the body?
80.
So 80.
80.
So 80 over 10. So the time taken to reach the maximum height is 8 seconds. So once you have this T, let's put it in. The maximum height, H max is equal to 80 times 8 plus half times 10 times 8 squared. So it means that we have 64,0 plus, this is 5. 5 times 64. And what is 5 times 64 plus 640?
$960.
Okay. So we have 960. So by this relation, we are told that the maximum height is 960. Let's see if we can get the same thing using U squared over 2G. So this is 80 squared divided by 20. So 6400 divided by 20. So we have 640 over, oh, they are not the same. What is missing? Let's see. H is equal to UT. Let's confirm. 80 times 8, 640. 64 times 5. Let's confirm 64 times 5.
$320.
Pardon? Pardon?
$320.
320. This is 64.
120.
So this is 960, as Sappho said. Then here we are also using v squared is equal to u squared plus minus. Okay. I've seen what is wrong. What is wrong is we are going up, so this must be minus. We are looking at when the body is going up, the deceleration is due to gravity. So it must be 640 minus, is that 300 and what? So this must give us 320. Then this is also 64 divided 640 divided by 2. So this is also 320. So both situations are giving us the same results. Please, is that okay?
Yes, please.
So that is the H max, maximum height. Now, if H max is here, if H max, how do we determine this height when it is falling from the maximum height range to the top of the roof? We know the initial velocity, we know the final velocity when it lands on the, how do we determine this height? Y, let's label that height as Y. How do we determine it? Because if we could find Y, we can easily find the height of the building. So I'm waiting for you. Think through it. Engage your brains for about 3 minutes and then share with me what you found before I also go through with you. Is that okay? All right. Do I have people in the building?
Yes, please.
I'm giving you text. Respond.
Yes, please. Mr. Dua,
Yes.
please, what are we supposed to do?
Janice, your attentiveness is a problem. Your attentiveness, Janice, is a problem. I told you that the ball has been thrown, is now at the maximum height. As at when it is dropping, it came to land on the top of the roof with a certain velocity equal to 60 meter per second. So we know the velocity at the maximum height. U is 0 because it's free falling. We know the velocity when it fell onto the roof. V is 60. Let's find the vertical height traveled, Y. So knowing the initial velocity, knowing the final velocity, we can determine Y so as to determine the height of the building. That's the task I've given you. Are you okay?
Yes, please.
Hello. Good afternoon. I'm afraid. The last time in any sign or say on your malaria. So the one call wrong. Oh. But they offer you so it's what hospital. Oh. Oh. Okay. All right. Yeah, me record the video. And then apply your understanding. Okay, I need Y. So what do I do? If I have this and I have this, what do I do? Think around. That is why I give you the work to do it. Let's see what you can do before. But sometimes you students fails to also apply what you have understood. That is the problem. So use both this equation and this to find H. For the first equation, you need to use this to determine the time. So once you get the time here, you substitute the time into equation 2. Then in the second equation, you have V, you have U. You are looking for H. So do it, and then let me see what you have. After that, you calculate for the height of the building. When you get Y, you then determine the height of the building for me. Go ahead. What have you made for Y?
Say please 180.
So did you get the same value for equation 2 and 3?
Yes, please.
So if you use equation 3, then you need T. So T will be equal to V minus U. U is 0 over G. So V is 60 divided by 10. So this is 6. So if I use equation 2, then H would be equal to, this is 0, UT is 0, half times 10 times 6 squared. So this is 36 times 5. And what is 36 times 5?
180.
So 180 meter. If I use equation 2, you have 60 squared, u is 0, divided by 20 will be h. So 60 squared, 3600 over 20. Over 20. You have 360 divided by 2, which is 180. The same value. So that is how to use the different equations. Please pay attention. Next time when there is a need for you to apply, you should be able to apply. Okay. Janice and Safo, is that okay?
Yes, please.
So if the height from the maximum height to the top of the building is 180, what will be the height of the building itself? How do we determine the height of the building?
(960 minus 180).
Come again.
960 minus 180.
560.
960. 960.
Why 960?
Because that was the height for the first, the upward motion.
Janice, how do we get the height of the building?
Sir, please, 320 minus 180.
So we had the maximum height, H max, to be 320. That's the height from the ground to where it's reached. So if it is falling from the maximum height and it's landing on the building, top of the building, and you are getting the distance from the maximum height to the top of the building to be 180, how do you get the height of the building itself to be 960? The whole height from where it's reached to when falling to the ground is 320. So it should be 320 minus 180. Or how did you calculate? How did you determine the 960? Let me know. So how did you come by 960?
Because I was using the previous one, the wrong one.
But are you okay with how to get the height of the building?
Yes, please.
So H max is 320. From the maximum height, which is this point, to the top of the roof, it's 180. So if I want this length, I subtract this from the whole maximum height, and that's all. 320 minus 180, please. Okay, let's solve another question, and then we go through. Okay, I'll forward another question to you.